Hello, and welcome to Sleepy Scientist. I'm glad you're here, whether you've had a long day, a busy mind, or you simply love falling asleep to the sound of science. Tonight, we're headed somewhere icy and impossibly high, where wind howls like ancient spirits and clouds cling to jagged peaks like soft cotton caught on thorns. We're going to a place most people imagine only as dry, frozen, and lifeless. But beneath the white silence of Mount Everest, something unexpected glimmers. Hidden far below the glaciers and scree tucked deep beneath the frozen crust of the tallest mountain on Earth. There are lakes, liquid ones. They're quiet, patient, almost invisible. But they're there pools of ancient meltwater, lying cradled in the cold dark, softly rippling without a whisper of wind. So slip into something cozy, lie back and let your mind hike with me, far above the tree line, then even higher until the oxygen thins. The stars thicken, and the great white mass of Everest rises around you. And as we descend, not up, but in, you'll see the mountain's true mystery is hidden not in its height, but in what stirs beneath. If you enjoy these sleepy explorations, I'd be so grateful if you gave the video a little like and tap that subscribe button. It helps more sleepy scientists like you find their way here, and it means I can keep making more of these journeys for you now. Close your eyes. Feel the snow crunch softly beneath your boots. The sky above is an endless, aching blue. Everest, or Chomolungma, the mother goddess of the world, towers before you, like a sleeping colossus draped in cloud and silence. You take a breath, shallow and crisp. Up here at over 8,000 meters, the air's only about a third as dense as sea level. Each inhale feels like drinking through a straw made of silk. Thin cold, barely enough. And yet, it's not just sky up here. Something else hides something unexpected. A secret the mountain keeps beneath its ice-laced skin. Most people see Everest as the peak of rock snow and glory. But you're here to listen deeper. Because Everest, though crowned with ice, holds water in its quiet belly. Not rivers, not waterfalls, but lakes. And not the kind that sparkle under sun-dappled skies either. These lakes are hidden, buried, trapped beneath glaciers in complete darkness. They lie deep under compressed snow and ancient ice in pockets where pressure and heat perform an old patient magic. How can there be water, liquid water, under the frozen crust of the highest point on Earth? That's the mystery. You imagine Everest as an enormous frozen sponge, layer after layer of compacted snow turned to fern, then to glacier ice. The weight alone, millions of tons of frozen time, presses downward. And below, where the Earth's crust never quite forgets its warmth, heat gently rises. It only takes a little warmth, a whisper, a breath. Because ice, for all its stillness, is more like honey than stone. It creeps, it flows, and as it moves, it grinds rock into dust. That friction adds heat, add pressure, add just enough geothermal nudge. And somewhere trapped between layers of glacial memory, a lake begins to form. The water doesn't freeze, not because it's warm, but because it's protected. The thick, insulating blanket of ice above prevents the heat from escaping. The pressure lowers the melting point. It's like a mountain-sized thermos, keeping pockets of ancient meltwater from becoming solid again. And that's where you're heading. You're not just climbing Everest, you're diving beneath it, gently descending through time, temperature, and pressure. You're walking upside down into a dream of hidden lakes, still dark old. Ask yourself, what does stillness feel like when it's had millions of years to settle? What stories does water carry when it hasn't seen the sky in ages? Even now, scientists aren't sure how many of these lakes exist beneath Everest and its neighboring ranges. They're not seen directly, not yet. But with satellite radar, seismic listening, and careful core samples, whispers have emerged. Some are just a few meters deep. Some may stretch wide beneath the ice like forgotten mirrors. And they're not empty. They carry chemicals, traces of oxygen, methane, iron. Some even harbor tiny strange microbes adapted to the pitch-black cold, thriving on minerals instead of sunlight. You'll meet them soon. For now, let yourself imagine the lake's surface flat black, as smooth as glass. Above it, hundreds of meters of ice pressed downward, motionless to the eye, but slowly shifting. Below, stone. Earth, a memory of mountain heat. And in the middle, a lake that doesn't move, doesn't speak, but somehow waits. Water older than the Himalayas. Older than you. Older maybe than the language you use to describe it. You sit beside it in your mind. No sound, no light, just the pressure of the world above and the pulse of something slow and certain beneath. The wind coils around the ridgelines like a shawl made of breath, and snow sighing over Everest's flanks with the quiet of a lullaby. You stand there, boots planted on centuries of compacted snow, and beneath you, hidden from the sun, unseen by trekkers and climbers alike, Mount Everest breathes. Water. Yes. This colossal peak, often imagined as frozen solid, actually inhales and exhales moisture through its slow-moving glaciers and fractured rock. Everest is not a static monument. It's a living, breathing body of stone, ice, and movement. It leaks, it flows, it stores, and it transports water in ways most of us never consider. The snow that falls on Everest doesn't stay fluffy and soft for long. With each storm, each passing season, it is pressed tighter and tighter, snowflakes crushed into fern, then eventually into dense blue ice. That ice begins to move, flowing down and outward as a glacier, a frozen river sliding over stone. But glaciers aren't dry, not completely. As they move, the friction between the glacier's base and the mountain below generates heat. Even the weight of the ice pressing down adds pressure that lowers the freezing point. Meltwater forms thin films, droplets, sometimes even rushing streams, trapped beneath the glacier's belly. Imagine a slow, secret plumbing system under the mountain. Some of this water flows toward the surface, eventually spilling out into glacial rivers like the Dudkosi or the Botikosi. But some of it stays. It puddles in old depressions, fills fractures, and collects in hidden bowls, carved long ago by ice. These pools, small, cold, isolated, are the birthplaces of subglacial lakes. Ask yourself, how does water know when to flow and when to stay? What decides whether a droplet becomes a river or a secret? Kept the glaciers themselves whisper hints. Let's look at the Khumbu Glacier, the most famous one on Everest. It sprawls down the mountain's southwest face, over 17 kilometers long, and it's alive, not just frozen in place, but constantly shifting, creaking, melting, refreezing. Scientists studying this glacier have noticed unusual pockets, small dips, areas where the surface sinks unexpectedly, as if something beneath it is not as firm as expected. These anomalies are signs of subsurface water. They suggest the presence of melt ponds and potential lakes lying quietly underneath. It's not just the Khumbu either. The Imja Glacier, not far away, has developed an expanding supraglacial lake, meaning a lake that rests on top of the glacier rather than beneath. But deep below, hidden from even satellite eyes, could be water, resting in long-buried rock basins, trapped by layers of ice. Here's the marvel: these lakes don't just receive water, they also breathe it out. Sometimes under great pressure, subglacial lakes leak. A crack opens, a tunnel forms, and suddenly, hundreds of millions of liters of trapped water can surge downhill in a matter of hours. These are called glacial lake outburst floods, or GLOFs. And they're terrifyingly fast. A flood of icy water bursting from a secret lake, racing down narrow Himalayan valleys, tearing through villages and bridges and anything in its path. But not all leaks are dramatic. Many are slow, gentle, steady like sighs from a mountain's lungs. These constant flows feed the mighty rivers of Asia, including the Ganges, Brahmaputra, and Yangtze, which begin in these glacial highlands. So Everest, cold and crowned in white, is one of Earth's great water towers. It stores and supplies fresh water for more than 1 billion people. Its snowfields feed the rivers that irrigate fields' power turbines and shape civilizations far below. And yet it hides just as much as it shares. Ask again how many secrets can a mountain keep in its frozen folds, and how many melt each year, drop by drop, as the climate shifts. Even now, as you listen, the glaciers of Everest are changing. Warming temperatures creep higher and higher, nibbling away at their frozen mass. Ice that once took centuries to form now melts in seasons. And with each melt, more water moves, more pressure builds beneath the surface, and more hidden lakes are born. You picture one now, a liquid hollow nestled between ancient rock and newer ice, dark as obsidian, quiet as sleep. It doesn't ripple, it doesn't steam, but it exists, maybe 5 meters wide, maybe 50, maybe just deep enough for microbes to dream their slow mineral dreams. You reach out your hand just in your imagination and let your fingertips hover above its cold surface. No reflection, no sound. Just the weight of a mountain and the secret of meltwater moving like a heartbeat no one can hear. You kneel in your mind beside the invisible shore of a hidden lake so close to the roof of the world, yet sealed beneath meters of ice. This is not a lake you can boat across or see glittering in the sun. This one is trapped in time and darkness deep in Everest's underbelly. And still it moves. You wonder, how can something so cold, so deeply buried, remain liquid, because by all logic it shouldn't. Everest's summit averages a brisk 36 degrees Celsius in January. Even in the lower Khumbu Valley, the air rarely gets cozy. Yet here you are, imagining your hand tracing the edge of a hidden pocket of water. Let's gently crack open the mystery. Water doesn't just freeze at 0 degrees Celsius, not when it's under pressure. Beneath hundreds of meters of glacial ice, pressure shifts the rules. Imagine thousands of tons of frozen weight pressing downward, compressing the molecules of both water and ice, nudging the melting point downward. It's like the laws of physics put on a cozy sweater and soften around the edges. Now stir in just a little warmth, not heat like a fire, but gentle, persistent warmth from the Earth itself. The planet's interior hums constantly with energy. This geothermal warmth, typically 25 to 30 milliwatts per square meter in the Himalayas, isn't enough to melt a glacier outright, but it accumulates. Add another source: friction. As glaciers slide over rock, they create subtle warmth. It's not fiery, but over time, it's enough to soften. Between pressure, friction, and geothermal energy, a small pocket in the base of a glacier refuses to freeze. Water accumulates, flows, slows, and becomes still. And just like that, a subglacial lake is born. Ask yourself, what does it mean to be warm enough to resist a frozen fate? And how long can something remain hidden yet entirely real? These lakes are not huge, not by surface area anyway. Most are a few meters deep, a few tens or hundreds of meters wide. But what they lack in size, they make up for in mystery. Because they are cut off from air, from light, from time in some ways, some subglacial lakes in other parts of the world, like those in Antarctica, haven't seen the sky in over 1 million years. Though Everest's lakes are younger, perhaps thousands to tens of thousands of years old, they share a similar sense of isolation. And inside, not just water. These lakes carry sediment scraped by glaciers and deposited like old letters into still envelopes. Dust from ancient volcanic eruptions, pollen from forgotten forests, even cosmic particles that drifted down during quiet nights long before you were born. They also carry chemistry iron, sulfur, methane. These ingredients mingle in the dark like a laboratory sealed from the world. Now imagine what if there's life inside tiny organisms, invisible to the eye, quietly thriving, not on sunlight, but on chemical reactions, not racing through life, but creeping slowly, adapting to low temperatures and no oxygen. These are extremophils, the microscopic explorers of the harshest worlds. You picture one, maybe a bacterium with a twisty tail spinning slowly through the cold. It breathes iron. It digests rock. It reproduces every few weeks, not minutes. Its whole life plays out in slow motion, a ballet beneath the ice. And it's been doing this long before climbers ever set foot on Everest. You feel a kind of awe, don't you? Because we often think of water as a surface thing, a thing that splashes, runs, reflects light. But here it becomes something quieter. A witness. A quiet keeper of time and chemistry, locked beneath a world of noise and wind. Sometimes scientists get lucky and tap into these subglacial lakes during field studies, like melting a small borehole through the glacier to draw out samples. What they find is both thrilling and humbling: bacteria that haven't seen daylight in tens of thousands of years, quietly metabolizing minerals, thriving in isolation. And every drop of water tells a story. A drop might say, "I melted from a snowflake that fell 500 years ago." Or, "I've circled beneath this glacier 36 times, carried by pressure and time." Or even, "I've waited here unmoving since before humans wrote poetry." Let that sink in for a moment. Now ask, if water can hold memory, what dreams must it keep under Everest? And what might we learn from something so persistently silent? You lie still, mentally weightless, in that dark, pressurized lake beneath the tallest mountain on Earth. You feel no current, no pull, just a hushed stillness. The mountain groans faintly above you. It shifts, its icy skin slowly adjusting. But the lake doesn't flinch. It has no need to hurry. It has already outlasted empires. You float with it, patient, listening. You're drifting now, gently through a narrow crevice of thought carved in crystalline ice. Light doesn't reach you here, but you don't need it. Your senses adapt slowly, attuning to the hush of Everest's inner world. And then, with a soft mental turn, you're floating not beneath the mountain, but beside two of its most precious companions, Gokyo and Khumbu. Not the glacier this time, but the lakes, the real visible shimmering ones. These are the lakes that sleep in the sky, cradled in high valleys, seemingly painted into the rocks. They may be easier to spot than their subglacial siblings, but don't let that fool you. These lakes, too, are steeped in silence, mystery, and ancient glacial breath. Start with Gokyo Lakes. Perched at 4,700 to 5,000 meters. Above sea level, this chain of lakes lies west of the Ngozumpa Glacier, the longest glacier in the Himalayas. The air up here is delicate and faint, like lace. Your breath comes slower. Everything feels exaggerated: the blue of the sky, the glare of snow, the way even your heartbeat sounds louder in your ears. The lakes are an impossible turquoise. You wouldn't expect such brilliant color at this altitude, but it's real, caused by rock, flour, fine sediment, ground down by glacial movement, and suspended in the water, scattering light just so. These minerals paint the lake with unreal vibrance, as if they've absorbed the sky itself. There are 6 main Gokyo lakes, and each has its own mood. The third lake, Dud Pokari, is the most visited, sitting like a calm blue mirror beneath the towering shadow of Cho-Oyu, the sixth highest mountain on Earth. But you drift now to the quieter ones, the fourth and fifth lakes further north and seldom reached. Here the landscape feels untouched. Wind whispers stories in your ear. The water doesn't ripple, it simply waits, surrounded by moraine walls and scattered ice. Now breathe deeper and let yourself shift eastward to the Khumbu region, specifically the high-altitude melt ponds and glacial lakes forming near Imjatse Island Peak and the Khumbu Glacier. These lakes weren't always there. Many are newborns birthed over the last several decades as ice retreats and hollows fill. You may ask, why is this important? What do visible lakes have to do with the hidden ones? But that's the beauty of Everest. It doesn't draw hard lines between above and below. Some of these surface lakes may connect to subglacial systems. Water moves in strange ways under ice and stone. A supraglacial pond, those shallow sunlit melt pools that form on top of glaciers, can seep down through cracks and moulins, glacial shafts into internal passages. A lake above may feed one below, a chain reaction of melt movement and memory. And if enough meltwater accumulates, a supraglacial lake can become a proglacial lake, resting at the foot of a glacier, or even punch through to form or join a subglacial lake. It's a watery dialogue between the world we see and the world we don't. Now lean back in your thoughts and imagine Everest not as a mountain, but as a vast, icy organ pumping water in pulses through secret veins. The Gokyo lakes are like glimmering eyes watching. The Khumbu melt ponds are like pores sweating under a warming sky. And the subglacial lakes, they're the heartbeats, slow, unseen, essential. Ask yourself, how many lakes are we walking over without even knowing it? And how many more are yet to form as the glaciers continue their quiet retreat? There's a soft sorrow to it, isn't there? Because these high lakes are also a warning. Their growth, especially those near Khumbu, is a sign of warming. Climate change melts more glacier each year, and lakes like Imjatcho, now over 60 million cubic meters in volume, are growing dangerously large. They shimmer with beauty. But beneath that beauty lies tension, like stretched skin over a bruise. If the moraine walls holding them break, especially during an earthquake or even a heavy storm, they could unleash massive floods downstream. Villages like Farish and Namche Bazaar lie in their shadow. And yet, even knowing that risk, the lakes are still impossibly peaceful. They don't hum with fear. They simply exist a balance of time and melt and gravity. You sit beside one now in your mind. The sky is an ocean overhead. The lake below is another sky. And somewhere between the two you float warm, despite the chill, weightless, despite the height. Above you clouds drift. Below you water whispers secrets it will never say aloud. And Everest continues to breathe. Stillness settles around you like falling snow, layer upon layer of quiet. As you lie there nestled between shimmering thoughts of Gokyo and the creaking pulse of the Khumbu Glacier, you begin to feel the pressure. Not from the air, though even now, it's thin and elusive, but from the weight of what lies above. Because beneath Everest's frozen face, beneath its sprawling tongues of ice and powder, lies a quiet but relentless force pressure. You wouldn't think of water here, in this frigid cathedral of rock and wind, as being hot or even warm. But in the private rooms of the glacier's interior, where light never falls and no breeze ever stirs, physics begins to lean in odd directions. It all comes down to a mountain's version of a pressure cooker. Imagine layers of snow falling winter after winter, settling gently on Everest's flanks. Each flake is innocent, delicate, short-lived, but together they become a kind of memory, a press, a weight. As snow compresses into firn and then to glacial ice, it thickens into something dense, heavy and cold, beyond imagining. And this weight doesn't just sit still. It presses downward, every gram of it, contributing to the invisible force acting on the mountain's frozen interior. Down in the guts of the glacier, pressure can reach tens of atmospheres, enough to crush air bubbles into shapes, enough to squeeze water into states that defy intuition. Water is peculiar. It freezes at 0 degrees C unless you change its world. Add enough pressure, and that point slips. Now, under Everest's crushing grip, water refuses to freeze even at well below freezing temperatures. So now you have pressure lowering the melting point and geothermal heat rising gently from below. Earth's interior warmth is subtle, maybe 25 to 35 milliwatts per square meter in the Himalayas, but the glacier above acts like an insulating quilt. That warmth has nowhere to go but up, and it accumulates in the narrowest spaces. Then there's friction. As the glacier slides, creeps really against the mountain bedrock, it grinds and groans, and that creates just enough heat to help melt its own base. All together, these forces conspire. Pressure, heat, friction. They work slowly, invisibly for years, decades, even centuries, until suddenly, there it is. A lake. A dark, closed, secret pool. Its water is not warm to the touch, far from it, but it is liquid, held in that fragile, precise equilibrium between freezing and flow, like a note held at the perfect pitch. Now ask yourself, what does pressure feel like when it is patient, and how much warmth can hide inside something that seems so impossibly cold? You picture the lake now, not just as a body of water, but as a creature hibernating under tons of ice. Its skin is the glacier above. Its breath is the slow movement of melt. Its heartbeat is the flexing of bedrock beneath it, geological and ancient. Some of these subglacial lakes under Everest may be small, just a few meters deep. Others could be larger, pooling in old bedrock basins or spreading through networks of interconnected pockets. We don't know exactly how many exist or how large they are, but they are there, hinted at by radar reflections and faint changes in glacier movement. Scientists are still mapping them, bouncing radio waves off the ice to find places where the signal returns just a little slower, where the ice seems to float slightly above something softer. Water. And when these lakes leak or burst, the pressure they've held so long suddenly releases. The result, a glacial outburst flood or geel-off. Imagine a lake that's been locked in darkness for 500 years, suddenly finding an escape hatch. A crack, a crevasse, a weakness in the ice. What had been still and quiet becomes swift and furious water rushing through frozen tunnels with the strength of 1,000 garden hoses. It surges out of the glacier's toe, carving valleys, dragging rock, snapping trees like twigs. But not all pressure releases in catastrophe. Some lakes let out slow whispers of melt, gentle leaks that join the larger water systems of the Himalayas. These rivers, the Arun, the Dudh Kosi, the Ganges, are not just fed by snowmelt. They are fed by breath, the glacier's slow and patient exhale. Think of it this way: every cup of tea in Kathmandu, every rice field in Bangladesh, every lotus floating in a still pond, all are nourished by this invisible system, this pressurized miracle high on Everest. And you're just floating inside the dream of it, letting your mind listen to the glacier as it groans, sighs, and warms, just enough to weep. You wonder now, what would the lake say if it could speak? Maybe something like, "I am held in place by pressure, but I am not trapped. I do not freeze, though everything around me is ice. I move, but no one sees it. I exist, though no one believes I should. I am the warmth inside the cold, And in your own way, so are you. You're deep now, far past where the sun can reach, far past the echo of snow boots or the sharp ping of an ice axe. And yet there's movement here, even in the quiet. It begins as a tremble, subtle as a thought beneath the invisible lake you drift above in your mind. Because the glacier isn't resting. It shifts, it creaks, it flows. And with it the water beneath stirs too, not with chaos, but with purpose. And now, just as the lake hides within the glacier, currents move within the lake itself. They don't roar, they murmur, but they matter. Have you ever thought of water as having intention? In a hidden lake beneath Mount Everest, the water doesn't sit completely still. It circulates guided by the shape of the rock basin it rests in, by the uneven warmth rising from below, and by the glacier's immense weight pressing from above. Like a quiet clock made of melt and memory, the lake keeps time with internal tides. And you, dreamily curious, begin to follow one. Picture a stream of slightly warmer water rising from a patch of geothermal warmth near the lake bed. That warmth isn't much, just a few tenths of a degree, but down here even that is enough. The water becomes buoyant, drifting upward through the lake's body, only to cool as it touches the underside of the ice above. Now it sinks again, forming a lazy loop, like the slow breath of a sleeping creature. Around and around it goes. This movement is called convective circulation, and in some of these lakes, it's one of the only signs that time is still passing. Ask yourself, how can something be almost frozen and yet still alive? And what might a current dream about as it loops for 100 years in the dark? These subglacial currents carry not only warmth, they carry nutrients. Bits of iron scraped from the rock below. Trace elements released by grinding stone and ancient dust. They carry gases too. Methane and carbon dioxide released slowly from the lakebed or frozen into ancient sediments and reawakened. All of it stirs gently, invisibly, feeding any microbial life that may cling to the edges of this underwater world. In places like Lake Whillans and Lake Vostok in Antarctica, scientists have drilled into subglacial lakes and found entire ecosystems of extremophiles, tiny slow-living organisms that metabolize, rocks survive without sunlight, and trace their lineage back before humans learn to whisper. Could Everest's hidden lakes hold similar life? It's not impossible. While no one has drilled into them directly yet, because of their inaccessibility and extreme depth, scientists have used ice-penetrating radar and satellite gravimetry to suspect their presence. And if there is water, warmth, pressure, and time, life tends to follow. Even now, research teams are planning and imagining, what if we could send a robotic probe down a borehole to swim through these glacial waters, like a space explorer gliding through Europa's icy crust? What would it find, clinging to the lake's edge? Would it find a living cell, a fossil, a new shape of existence altogether? You follow your thought like a current swirling softly through the water. You sense the lake is not passive. It responds. To the glacier above, to the Earth's breath below, to the changing climate outside its frozen walls. And as the ice above melts faster and faster with each warming season, the balance of the lake changes. More meltwater enters, the pressure builds, the currents shift. What had been stable for decades may become restless. Some lakes once sealed perfectly may find new cracks escape routes. Others may grow quietly, creeping along bedrock, forming subterranean arms and tunnels. The lake that had once been a rounded, tight bowl might stretch out like a sleepy cat, exploring its old icy prison. And one day, maybe it will break free. That's the fear that keeps some Himalayan researchers up at night, that these invisible lakes could burst. Not slowly, but all at once. Glacial lake outburst floods. GLOFs have already happened in places like Bhutan and Nepal. Water trapped under a glacier suddenly finds a weakness, a path out, and races downslope like a runaway train. Villages can be swallowed, fields erased, bridges snapped like twigs. A lake's silence transforms in hours to a voice too loud to ignore. But most of the time, it doesn't. Most of the time, it just keeps flowing inside itself. And that's the beauty of it, because not every story needs to end in drama. Some stories, like water, prefer to loop. You float now in the lake's rhythm, around and around, buoyed by warmth too faint to feel pulled by a current older than your memory. No need to swim, just listen. The lake will carry you the way it carries iron and warmth and time. And as you drift, you feel something you can't name. Is it sadness? Is it awe? Or is it just the slow, secret satisfaction of knowing that beneath the tallest mountain in the world, something ancient is still turning in circles, patient and undisturbed? You linger in that dreamlike swirl, adrift in the loops of invisible currents. But even the gentlest motion brings you closer to the walls of the hidden world beneath Everest, the lake's silent container, its patiently carved bedrock basin. And now you drift downwards slowly to press your thoughts against that ancient surface. It's not smooth. No, the bed of this lake is uneven, like time has run its fingers through it. It's grooved and rutted, cradling sediments, whispering minerals back into the water above. Imagine for a moment that you're the lake. What does it feel like to be held in a vessel shaped not by hands, but by ice and pressure? The glacier above hasn't just sealed the lake, it formed it. Over thousands of years, perhaps tens of thousands, ice scraped along the Earth's skin like a slow, cold sculptor. It pressed down with unimaginable weight, grinding rock into smooth bowls, gouging out hollows, plucking chunks of stone as if pulling loose teeth. The result: a glacial over-deepening a depression in the valley floor, sometimes hundreds of meters deeper than the surrounding terrain. It's a basin, a cradle, a wound in the earth that filled eventually not with sorrow, but with water. Ask yourself, what kind of memory lives in a stone bowl beneath a mountain, and how far back do its stories go? The Himalayas are young, geologically speaking, formed just 50 million years ago when the Indian tectonic plate slammed into the Eurasian plate. That collision still continues inch by inch. It's the reason Everest rises each year by about 4 millimeters. But beneath Everest's glacial lakes, the bedrock tells a more ancient tale, one that predates the mountain itself. Schists, gneisses, and granites whisper from the lake floor. They're the bones of vanished continents, melted and reformed deep underground before ever seeing the light. Over hundreds of millions of years, they were pushed upward, exposed, buried again, and finally worn down by the relentless kiss of ice. You're now resting gently atop this layered, silent witness. The water above you carries traces of these rocks, dissolved ions of calcium, magnesium, sodium. Sediment too glacial flour, too fine to settle, held aloft by the lake's slow breath. If you could run your hand along the floor, you might feel ridges, striations left by glaciers that passed long ago. Or you might feel the fine silt of sediment falling like snow, bit by bit for centuries. Every particle a time traveler. And sometimes the bed isn't smooth at all. Instead, it's riddled with crevices and fractures where geothermal heat escapes or where gases bubble slowly upward. Methane, carbon dioxide, even hydrogen sulfide in trace amounts. This turns the lake floor into something alive, a landscape that exhales, and life. Even here where the sun has never touched. Well, that's where things get even more poetic. At the interface between rock and water, microbes can cling and thrive. These are chemosynthetic organisms, creatures that don't need sunlight. They feast instead on iron or sulfur or methane. They don't bloom or glow, but they persist forming biofilms on stone or drifting slowly above the silt. You picture one, now let's call her a bacterium named Miri. Miri floats gently above a vent in the lake bed where a whisper of warmth leaks from the Earth's belly. She senses iron and swims toward it, slowly twisting her flagella like ribbons in syrup. When she finds it, she metabolizes it, turning geology into energy, rock into life. She's tiny, unimaginably small, and yet she carries with her a memory chain of 1 billion years of evolution. Her ancestors might have lived in the oceans of early Earth, and now she makes her home here, in this unseen lake, beneath the world's highest peak. How many more Miris are there? What hidden biospheres might these lake floors shelter? And if such life can thrive in silence, in dark and cold and pressure, what might this say about other worlds that thought lifts you gently like a bubble rising? Because this lake in its silence is an analog, a model for places far beyond Earth. Think of Europa, the icy moon of Jupiter, or Enceladus circling Saturn. Both are believed to have liquid oceans beneath their frozen crusts, warmed by tidal forces instead of sunlight. They may harbor hydrothermal vents. They may cradle alien bacteria in lakes that will never know sky. So in a way, when you imagine yourself floating above this subglacial lake's floor, you're not just beneath Everest. You're peeking into the possibility of life beyond our world. You feel a kind of reverence now, because the lake is not just water. It is stone and history and pressure and chemistry. It is ancient and evolving. It holds secrets not meant to be loud. It cradles stories in the quietest way by enduring. And so do you. You rest a little deeper now, warmed not by the sun, but by the slow secret heat that rises from the planet itself. As you drift still and soft in thought, you begin to feel the pulse of something bigger, a rhythm not of one lake, but of many. Because the lake beneath Everest isn't alone. Beneath the roof of the world, under glaciers that slide like time, lies a network of hidden waters. Some connected, others isolated, all shaped by the same delicate equations of pressure, ice, and flow. You're not just visiting one secret. You're wandering into an entire under-ice symphony. Take a gentle breath and imagine the glacier as a honeycomb of secrets. Thin, icy corridors stretch like veins, linking one lake to another in a slow, whispered circuit. These are subglacial drainage systems, natural plumbing carved by water, under pressure, sculpted by centuries of drip, pulse, and thaw. Some passages are broad and consistent, like glacial rivers. Others form as moulins, those vertical shafts that drop meltwater from the surface straight into the heart of the glacier, like trapdoors in the snow. And just like your own bloodstream, these hidden channels aren't static. They change. Some freeze shut in winter. Others pulse open in the warm season, responding to surface melt. Some grow turbulent during monsoons, when rain and meltwater cascade through the system like a wild heartbeat. Now pause and ask yourself, if the glacier is alive, then what are these lakes and channels? Are they its bloodstream, its thoughts, its dreams? They behave that way. Even small variations in pressure can redirect water from one chamber to another. What once was a solitary lake may suddenly share its burden with a downstream neighbor flowing silently under the mountain's ice-skinned body. And when enough water gathers, a lake can link up with the system, a secret society of water navigating by gradient and gravity alone. This brings you to one of Everest's most enchanting possibilities, that some of its hidden lakes aren't separate at all, but are part of a dynamic, interconnected subglacial system. This system isn't just geography, It's alive with motion and memory. Some lakes fill and drain in cycles. A radar pass from a satellite might show a bulge of water. One year, then nothing the next. Where did it go? Through a channel into another lake, or did it slowly seep into groundwater below? We don't always know, but the Earth does. Satellites like IcySat and CryoSat track subtle changes in glacier height, millimeters of shift that hint at water moving below. A depression here, a rise there. It's like reading a face through expressions, a smile of rising water, a frown of loss. And it gets stranger. Sometimes one lake's drainage triggers another. It's called a cascade event, and it's been observed in Antarctica, where one subglacial lake drained 2 cubic kilometers of water, enough to fill 800,000 Olympic swimming pools. And within months, radar showed another lake downstream had swollen with that very same water. It was a message passed through ice, a ripple of connection. Could Everest's hidden lakes do the same? It's likely. Though the Himalayan glacier system is less well mapped than Antarctica's early studies suggest, something similar might be happening. Small shifts in glacier velocity, changes in surface elevation. All hint that water is on the move, sometimes quietly, sometimes suddenly. You imagine now Everest's underbelly as a quiet choir, each lake a voice, each channel a breath. Together they sing a song no one can hear, except the mountain itself. And what would that song sound like? Maybe it's the sound of old meltwater pressing against new ice, of minerals drifting down in spirals, of microbial life stirring in the darkness. Or maybe it's silence itself, perfect, unbroken, resonant. But even silence has rhythm. These connected systems matter more than you'd think. Because water under a glacier doesn't just flow, it lubricates. It makes the glacier's movement possible. The more liquid beneath, the faster the glacier can slide. And when that water drains suddenly, the glacier slows, or halts, or changes course. So these hidden lakes don't just sit passively under the mountain. They steer it. They determine how fast ice moves, how valleys form, how meltwater reaches rivers below. They shape landscapes. They feed millions downstream. They remind us that what lies beneath a mountain is just as powerful as what lies above. You hover there in that awareness. A lattice of lakes and streams breathing together in the dark, carving their way forward through silence, more connected than anyone thought, more alive than they appear. And then you wonder what connects you. What silent channels do your thoughts follow? What underground lakes of memory and meaning shift gently beneath the surface of your life, unseen but essential? You may not have an answer yet. But like Everest's hidden waters, the knowing will come slow, soft, steady. You find yourself hovering now, suspended in the hush, between connections between one lake and the next, one tunnel and another. It's easy to forget how much is hidden, even in a place as tall and iconic as Everest. But down here, the secrets don't shout. They hum. And now, as you drift deeper into the dream of this glacier's underworld, your curiosity catches on something unexpected. A pulse, a signal. A vibration felt not by your ears, but in the quiet hairs of your imagination. Because beneath Everest's ice, scientists have detected the faint electrical breath of water. How it's called radar, sounding a technique that uses bursts of electromagnetic waves to probe through the ice and read the shape of what lies below. And just as bats use echolocation to see in the dark, these waves bounce off different surfaces, telling us whether what lies beneath is solid ice, soft slush, or liquid water. Some pulses return sharp and quick, others soften, stretching a fraction longer, like a sigh across silence. It's from these faint returns, these whispers in static, that we began to map the invisible. Lake, by lake, layer by layer. In one recent study, glaciologists used this technology to identify what they believe is a large subglacial lake system beneath the Khumbu region, possibly stretching dozens of kilometers, nestled between the ice of the Khumbu Glacier and the old Himalayan bedrock. It doesn't show up on maps. You can't hike to it. There's no glimmering blue on satellite images. But the signals don't lie. They speak of something smooth and flat, two rare traits in a glacier's underbelly, which is usually rough and craggy. And the echoes that come back from these areas are brighter, clearer, as if bouncing off polished glass rather than packed snow. That's the fingerprint of liquid water. And sometimes the signals even change over time. A radar pass in 2012 might return one pattern. By 2015, it's shifted, indicating water has moved, swelled, drained, or connected to something new. You pause here, your mind brushing against the question. If a lake can shift unseen, how many have done so already? And how many more are being born slowly in the glacier's hidden heart? Now close your eyes gently and picture the tools we use to uncover these mysteries. Tiny airplanes mounted with radar, satellites passing overhead like metal owls, ground-penetrating instruments dragged over ice by researchers with sunburned faces and frostbitten fingers. They listen, record, and interpret a language written in reflections and time delays. And even more remarkably, scientists can combine this with gravity data, sensing how mass shifts slightly in different areas of the glacier. Water is heavier than ice after all. Even the smallest changes ripple out in gravity's silent embrace. So much effort, so much patience, all to confirm something the mountain already knows, that beneath its surface it holds stories. It shelters delicate systems that live not in defiance of cold, but because of it. You start to wonder what else we've missed. What else lies beneath us every day, beneath cities, beneath oceans, beneath our very thoughts. If Everest can harbor lakes for centuries without a sound or shimmer to betray them, then surely there are wonders hiding in you, too, waiting for the right signal, the right question, the right moment to be found. Now imagine you're not drifting alone anymore. Beside you floats a tiny sensor shaped like a smooth glass bead. It's cold, but not inert. Inside it carries tools, a thermometer, a microphone, a miniature spectrometer. It was lowered into this lake not by fantasy, but by science, a mission to read what light can't see. As it glides through the water, it listens for vibrations. It samples chemistry. It tracks flow and temperature and pressure. And its quiet observations begin to build a picture not of surface beauty, but of inner structure. The lake, once invisible, begins to take form, not with colors, but with data, not with light, but with knowing. What's the temperature? Just below zero, perhaps, 0.5 degrees C, stabilized by pressure. What's the salinity? Low, but present minerals from the rock dissolved into the water, a fingerprint of Earth's breath. What's the oxygen level? Sparse, but measurable enough for microbes to cling to life. All this information gathered in silence, transmitted upward, turned into lines, graphs, maps. Proof that something hidden can still speak if you know how to listen. And so, wrapped in this dream, you realize this lake doesn't want to be discovered. But it doesn't mind being understood. It doesn't shout. It reflects. And maybe the mountain is whispering back. You float now in a hush so deep even your thoughts seem wrapped in frost. But the water around you still stirs gently, not from within, but from above. Because for all the mystery of what lies below Everest, it's the glacier on top that keeps these lakes alive. Let your imagination rise slowly upward, slipping past layers of dense ice. You're not climbing. You're melting upward like warmth in reverse. The glacier overhead is not just a ceiling, it's the lake's guardian. Its weight holds the water in place, its chill preserves it. Its slow, relentless flow determines how the lake breathes. But it's not a passive protector. No, this glacier is more like a living blanket, adjusting constantly to time and temperature, tightening or loosening its grip. And lately it's loosening. Because Everest's glaciers, like so many around the world, are melting. The Khumbu Glacier, which snakes down from the western face of Everest like a giant frozen tongue, is retreating, not in one loud collapse, but in a slow, sighing unravel. Over the last 50 years, it's lost more than 100 vertical meters of ice in some places. That means less pressure, thinner cover, warmer melt. So ask yourself gently, what happens to a lake whose ceiling is vanishing? At first, not much. The pressure that once held the water in place begins to ease. The ice that insulated the lake grows thinner, allowing a whisper of warmth from above. Meltwater from the surface finds new pathways downward. Some of it joins the lake, swelling it. Some escapes entirely, dragging minerals, gases, and even microbes away. The lake begins to feel restless, and yet it also begins to reveal itself. With thinning ice, satellites can begin to see hints of surface motion where none was noticed before. In some regions, what was once a cold-based glacier, frozen all the way through, becomes warm-based, in parts, with liquid water easing its path at the base. The lake, once completely sealed, becomes a conduit. This is the subtle transformation scientists now believe is unfolding beneath the Khumbu Glacier, and others nearby, that new hydrological networks are forming. Pathways that didn't exist 50 years ago. Channels being carved not by tectonic force, but by climate's quiet insistence. And the water is no longer still. It moves. It flows toward proglacial lakes, those beautiful glassy bowls that form at the glacier's snout. You've seen them in photos, turquoise framed by boulders and prayer flags. But their beauty masks attention. Because the water feeding them isn't stable, it's part of a system in flux. Some of that water comes directly from the melting glacier surface, but some of it may be released from subglacial lakes beneath, gathered slowly over decades, then draining in pulses through tunnels you'll never see. And once that water reaches the edge, it can build and strain, and rarely but catastrophically it can burst. This is the haunting power of a glacial lake outburst, flood a geel off. It begins in silence, often at night. A moraine dam weakens, a buried ice plug melts, and then millions of cubic meters of water surge down a valley in a matter of hours. Entire villages have been lost this way. Entire forests swept clean. In Nepal, Bhutan, and northern India, these events have claimed lives and landscapes. The Himalayas may seem timeless, but their valleys are marked by flood scars, earth gouged clean by a lake's brief fury. You pause uneasy, but let that feeling pass. Because this story isn't just about fear, it's also about knowledge. And knowledge in the hands of the thoughtful becomes a tool. In recent years, teams of scientists and local communities have begun mapping, monitoring, and preparing. With drones, satellite imagery, and even handmade sensor buoys, they're watching the lakes, learning their moods, forecasting their futures, and that includes the hidden ones, those beneath the ice. Because even if we can't see them, we now know they're changing. And by studying how glaciers melt and flow, we can begin to predict how the lakes below will behave. It's a quiet kind of science, part listening, part guessing, part waiting. Like stargazing but turned inward. And it's a reminder that everything is connected. The glacier above, the lake below, the river beyond. And the people who live downstream, where snow becomes drinking water and melt becomes rice fields. So when you imagine Everest's hidden lakes, remember they're not just secrets to satisfy curiosity. They're part of a living system. A mountain breathing through ice, a world melting but also revealing. And in that revelation there is a chance, not just to mourn what's lost, but to understand what remains. You sink slowly again now beneath the melting skin of the glacier. The lake welcomes you back not with drama, but with the same quiet that has held for millennia. But even that quiet is changing. And as it does, so does the story. You let yourself slip once more into the gentle hold of the hidden lake, deeper now, not in depth, but in understanding. The hush around you is no longer emptiness, but awareness. This lake, this cold cathedral beneath Everest, has begun to whisper more clearly. And what it says next you might not expect. It speaks not just of water and rock, but of life. That's right. Even here in the darkness, beneath the world's tallest mountain, surrounded by crushing pressure and an eternal chill, life finds a way. Let your thoughts move slowly across the lake's interior. Imagine drifting through microscopic clouds, faint floating clusters of single-celled organisms. Tiny architects of survival, invisible to the eye, but mighty in persistence. Here in this glacial hush, psychrophiles reign. Their name means cold lovers, and it suits them. These microorganisms thrive in sub-zero temperatures. Their cell membranes don't freeze like ours would. Their proteins are flexible, adapted to a world where energy trickles in rather than surges. You might picture one, now let's call her Aera. Aera floats in stillness, a bacterium smaller than a grain of sand's whisper. She carries inside her the memory of ice, ages past, of darkness unbroken, of chemical rhythms shaped by the rock beneath her. She doesn't need sunlight. Instead, she lives off chemicals that seep from the bedrock or drift in through the meltwater above. Like her cousins in Antarctica's Lake Vostok or Greenland's subglacial lakes, Aera belongs to a lineage that has never seen the sky. Ask yourself, could life exist without sunlight, without seasons, without air? Aera answers yes every moment of her existence. Some of these creatures use chemosynthesis, just as deep-sea vent organisms do. Others cling to organic molecules left behind by surface melt or glacier-ground rock. And when nutrients grow scarce, many can enter a kind of stasis, a microbial meditation, waiting patiently for decades, even centuries, until conditions shift again. And yet, in their stillness, they shape their world. These bacteria produce acids that break down minerals. They release gases that shift local chemistry. They form biofilms, thin, sticky layers that coat the walls of the lake, subtly changing how heat moves and how elements cycle. In essence, they engineer their own microenvironment, and they're not alone. In the shallower seasonal melt layers, closer to the glacier's surface, algae sometimes appear cold-tolerant strains that bloom briefly in slushy water before freezing again. Fungi, too, cling to life on glacial ice crystals, feeding on microscopic organic debris swept down from the surface. It's a world that pulses in extreme slowness. A world not of chaos or competition, but of adaptation, the kind that takes centuries to perfect. You begin to wonder now if life can thrive here in this frozen cradle. What does that mean for life elsewhere? That question sends you tumbling softly into a larger thought. Because the existence of subglacial microbial life on Earth offers tantalizing evidence that life may exist in similar environments beyond our planet. Europa, Enceladus, Mars. All of them are believed to have, or once had, liquid water beneath icy shells or ancient surface crusts. If hardy organisms like Aera can survive here under Everest, might her distant cousins be waiting beneath those alien ice sheets? You imagine a future spacecraft drilling into the crust of a Jovian moon, lowering a probe into a dark alien ocean. And there perhaps it finds something familiar, not because it glows or dances or builds, but because it persists. That's the gift these hidden lakes give us, not just water, not just wonder, but perspective. A map to where life can go and where it might already be. Now let yourself drift back to Earth, back to this lake beneath Everest. The water here is calm, but the science is rippling. In recent years, researchers have begun developing cleaner, more careful tools for exploring these hidden ecosystems. Special drills that don't contaminate the lake submersibles, that can navigate without stirring sediment labs, that can detect life in nanograms of water. The more we study, the more we find. Genetic material proteins, metabolic byproducts, tiny signatures that life is not only possible here, but resilient. So when you think of Everest, don't think only of climbers or wind-scoured peaks. Think of the quiet heroes beneath the microbial caretakers of a world no one sees. They're not the stuff of headlines, but they are ancient, and they are enduring. They've been here long before the first footsteps scraped the summit, and they'll likely be here long after. You exhale slowly now, because somehow knowing this changes how you feel about loneliness, about isolation, about silence. Even in the coldest, darkest place, something stirs, something lives, something waits to be known. You linger in that thought a little longer, the idea that even in the stillness life stirs, that even in darkness there's connection. But now let's lift gently again like bubbles drifting upward in cold water towards something you might not expect at the base of a mountain. Heat. It seems strange, doesn't it? Here beneath the world's tallest peak, where everything seems encased in permafrost, there is warmth, quiet, constant rising from below, like a breath exhaled by the planet itself. You're feeling it now in this dream space. A subtle hum beneath your feet, the Earth's geothermal heat. Because even Everest draped in ice and silence rests on a foundation that is alive with energy. And this energy plays a vital role in the secret life of the lakes beneath. Geothermal heat flow measured in milliwatts per square meter rises from the Earth's interior and seeps into the base of glaciers, warming the rocks, softening the ice, just enough to allow pockets of melt to form, not through friction or weather, but through Earth's own internal fire. And here's the fascinating part. The Himalayas, due to their complex tectonic history, have higher than average geothermal gradients in some zones. The collision between the Indian and Eurasian plates didn't just raise mountains, it created fractured dynamic crust where heat escapes in uneven but meaningful ways. So imagine the underside of Everest's glacier now, part pressure, part melt, part geothermal glow. This warmth is gentle, not enough to boil or burn, but enough to tip the balance. Where pressure alone might keep water frozen, geothermal heat nudges it over the edge. A small rise in temperature, just a few tenths of a degree, can make the difference between ice and liquid. Let that sink in. A single breath of warmth from the Earth's mantle can birth a lake. And once the water is there, it stores that heat, circulating it through the subglacial system like a whispered secret. It helps maintain the lake's existence. It softens the base of the glacier. It feeds the quiet flow of water beneath the mountain. But geothermal heat doesn't work alone. It collaborates. Friction from the glacier's own movement also contributes. As ice scrapes across bedrock, it generates heat, a slow grinding that produces just enough warmth to keep the base from locking solid. The heavier the glacier, the more pressure it exerts. The faster it moves, the more heat it makes. It's like the glacier is gently massaging its own underside, generating the conditions it needs to keep sliding. So you ask yourself, isn't it strange that the coldest places on Earth are only cold on the outside? Inside, they're humming, balancing the melt of ice with the fire of stone. And this balance creates not just lakes, but layers. Some glaciers have a thin film of liquid water at their base, even when the ice above is hundreds of meters thick. Others host perched lakes, small reservoirs sitting just above the bedrock, cupped in hidden hollows, like sleepy eyes beneath the skin of the ice. These lakes may not always be visible, but the geothermal heat, quiet and consistent, never truly stops. You float now in one of these lakes, thin, still fed by heat from below and melt from above, and you begin to realize how precise the equation must be for this to exist. Too much heat, and the ice above collapses. Too little, and the lake freezes solid. It's a balance measured in fractions of a degree. This same delicate thermal math may explain why some lakes appear suddenly, even in places where no lake was expected. All it takes is a shift, a drop in pressure, a change in glacier flow, a slow increase in geothermal flux, and ice begins to melt. A lake awakens. But geothermal heat does something else too, something quieter. It feeds the chemistry of the lake. As the water warms slightly against the rock, it leaches minerals ions of calcium, magnesium, silica. It becomes more than water. It becomes a solution, a medium for life, for erosion, for transformation. The bedrock dissolves ever so slightly, and the lake becomes a chemist's cauldron. This is how landscapes change from beneath, not with earthquakes or explosions, but with patient chemistry encouraged by Earth's warmth. And so the lake becomes a messenger, not just of water, but of geology, of the deep connection between heat and ice, between ancient crust and present-day climate. It tells you that nothing is truly isolated, not the mountain, not the glacier, not even this cold hidden lake. Everything is in motion, everything is in dialogue. And now maybe so are you. Because understanding geothermal heat beneath Everest isn't just about numbers and flow charts. It's about remembering that even in places that feel still, something glows. In you too there are pressures and warmths and slow internal tectonics shaping who you are, just out of sight. So the next time you feel cold or distant or buried beneath something heavy, remember the mountain is too. And still, it radiates. Quietly, patiently, from within. Now you linger a little longer beneath the glacier's skin, feeling its warmth and weight not as burdens, but as embraces, one from above, one from below. You are cushioned between forces that seem opposite but are in constant quiet cooperation. And yet, not all is still, because every lake beneath the mountain, no matter how hidden or ancient, is part of something larger, a restless, evolving network. One drop doesn't stay in place forever. Water remembers how to move. These subglacial lakes are not solitary. They connect, sometimes through narrow channels that pulse, open and closed, like tiny icy capillaries. Other times through sudden dramatic shifts, a hidden tunnel collapsing a path, unfreezing. The water rushes forward. The lake empties. And somewhere else beneath the glacier, another begins to fill. This dynamic is called subglacial drainage. And it's a dance few humans ever witness, but one that constantly reshapes the inner workings of the ice. Imagine it now. You're drifting in a chamber of still water, and suddenly something stirs. A whisper of suction, a distant trickle. The lake responds not with panic, but with purpose. Because these lakes are more than storage. They're part of a living circulatory system. Ask yourself this. How does water know where to go when it's surrounded by ice? It senses pressure. It reads the slopes of stone beneath. It follows hydraulic potential. A balance between gravity and friction, constantly recalculated with every melt, every freeze. It's a bit like water learning its own version of geography and rewriting it every year. One particularly fascinating behavior is what's known as episodic drainage. Subglacial lakes can stay sealed for decades, calm, still silent. And then without warning, they drain over a few days, releasing vast amounts of water through basal channels toward the glacier's front. We've seen this happen in Antarctica. We've seen it in Greenland. And now we suspect it happens beneath Everest, too. When that happens, something even stranger unfolds. The lake doesn't just disappear, it changes the glacier above it. The sudden movement of water reduces friction at the base. It acts like a lubricant, making the glacier flow faster for a time. You can almost hear the ice groan and shift, like a sleeper rolling over after holding still too long. This surge can accelerate the entire glacier by meters per day. Then, as the water finishes its run, the glacier slows again, returns to its sleepy crawl. But something has changed. A bit of stress has been relieved, a bit of structure rearranged, and sometimes the lake refills, beginning the process again. This cycle-fill pressurized drain is not unlike a heartbeat, a mountain's slow, silent pulse. And what's even more astonishing is that scientists have learned to measure this. Tiny GPS markers placed on the glacier's surface can detect when it suddenly rises or sags by centimeters or meters, clues that water below is moved. Satellites track the speed of glacial flow, watching for subtle accelerations that betray a hidden surge. Some sensors even pick up subglacial tremors, like faraway footsteps, telling of water crashing through unseen ice tunnels. And if you listen closely, this entire drainage network sounds alive. Tunnels that form and collapse, cavities that whisper and roar, ice ceilings that melt just enough to let a drop through. Glaciers are not monolithic. They are breathing bodies, and their hidden lakes are their pulse points. You might ask, is this dangerous? Sometimes yes. If drainage occurs too quickly, it can contribute to surface collapse, glacial flooding, or unpredictable changes in glacier movement. But more often, it is simply the glacier expressing itself. Adjusting, releasing, renewing. There's something poetic in that. To think that even a mountain needs to release pressure. Even a lake held in silence must eventually let go. Now imagine standing above all this, far up on the icefall with no idea what's happening deep below. You see snow, wind, sky. But under your feet, this whole silent network is active, calculating, adjusting, moving in ways you'll never see. It makes you think, doesn't it? How often do we assume stillness when really everything beneath is in motion? Your mind now is like the glacier, structured but dynamic, holding much, letting some things flow. And so you drift gently between chambers, following water that no map marks, listening for the murmurs of a system you now understand a little better. The hidden lakes are not alone. They are part of each other, and in that quiet unity they endure. And now you've reached the deepest part, not necessarily in meters or miles, but in meaning. You've followed hidden lakes from stillness to motion, from cold silence to geothermal breath, from solitude to intricate network. And here in this quiet center of Everest's underworld, a new truth begins to take shape. These lakes aren't just natural features, they're records. You might picture them now like ancient books, written not in ink, but in layers of trapped water, minerals, microbes, and time. Each one a library sealed in ice, whispering secrets that reach back hundreds of thousands of years. Because here's the wonder, even though these lakes lie in the present, they preserve the past. Their water is old, very old. Some of it melted from snowfall that first landed before humans built cities or carved symbols into stone. Some of it filtered down from glacial layers stacked during Earth's last ice age. In these hidden lakes, you can find traces of a time when mammoths roamed and the Sahara was green. And in those traces, clues. Tiny shifts in chemical composition tell us how Earth's atmosphere has changed. The ratio of oxygen isotopes reveals ancient temperatures. Trapped gases like methane and carbon dioxide whisper about volcanic activity or long-lost forest fires. Even the presence of certain microbes suggests how nutrients once cycled through oceans and soils. It's as if the lake, though silent, has been paying attention. Ask yourself this: what stories could the water beneath Everest tell if we learned how to listen? It could speak of rainfall patterns of dust blown from deserts far away, of ash drifting down from ancient eruptions, of the slow migration of heat from Earth's core. It could even warn us gently of what may come. Because just as the lake preserves ancient climate, it also reacts to modern climate. The melt rate of the glacier, the warming of the atmosphere, the acceleration of the monsoon. These lakes are changing not in sudden explosions, but in measured whispers. By studying those changes, scientists are learning how the Himalayas, often called Earth's third pole, are responding to global warming. The data from Everest's hidden lakes helps us model the future of sea level rise, water supply, and mountain stability. You float in this thought for a moment, buoyed by the quiet weight of it. A lake that no human has ever touched is helping humanity plan. It feels sacred, doesn't it? A secret space offering wisdom without demand, just waiting softly, patiently for us to understand. And yet these lakes are fragile. They exist at the edge of stability, pressed by glaciers, warmed by the earth, thinned by the sky. A few degrees more, a few meters lost, and they may vanish. Or worse, destabilize. Drain suddenly, shift violently. Take parts of the glacier with them. So the question becomes, how do we protect something we can't see? The answer lies not just in equipment or research, but in a change of perspective. We begin by seeing the hidden lake not as a mystery to solve, but as a partner to respect. Not as a problem beneath our feet, but as a mirror of our own complexity. Because in a way, you too are a layered being. You too hold ancient stories, quiet signals, buried warmth. You too have networks of flow, of emotion, of thought that no one else sees, but which shape everything you do. So maybe understanding Everest's lakes helps us understand ourselves, their patience, their quiet intelligence, their ability to hold on through immense pressure, to shift and release when needed, to adapt to what comes. Now take one last slow look around you. The lake is still here, calm, dark, enclosed in cold stone and colder ice. It has been here long before you arrived. It will likely be here long after. But for this moment, you and it have shared something rare: recognition, a glance across millennia. And that perhaps is the most precious thing of all. And now, in this final quiet descent through the dream of Everest's hidden lakes, you feel everything start to stretch wider, slower, deeper. The silence grows heavier, not in weight, but in meaning, and the water around you is not just liquid, but memory. Let your mind float in it. Let it settle like sediment at the bottom of a still pool. Because the hidden lakes are not merely subjects of science, they are places of wonder, of delicate existence, of unanswered questions wrapped in thick glacial quiet. And in their dark, cold corners, they are holding something else too. Possibility. There's one more thing these lakes might be doing, something we're only just beginning to understand. They may be helping shape the very mountain they sleep beneath. Yes, beneath Everest, water is not simply waiting, it's working. When these lakes drain or shift, the pressure at the glacier base changes. That affects how the glacier slides, how it pulls on the valleys below, how it cracks and crumbles and deposits debris. Over thousands of years, these tiny changes add up, and not just on the surface. Subglacial water can erode bedrock, carve channels, rearrange sediment. It acts like a slow sculptor, carving with invisible chisels, changing the mountain's base grain by grain. In this way, water becomes geology's silent apprentice, not as bold as an earthquake, not as flashy as erosion by wind, but steady, insistent. If you could fast forward 100,000 years, you might see how this watery whisper reshapes the feet of Everest. A slope gentled, a valley widened, a glacier retreated, a new lake formed. And maybe, just maybe, you begin to realize that no part of nature is ever truly alone, that even the tallest mountain depends on the quiet work of hidden things. Ask yourself again, what else in life is quietly holding everything up? What else unseen is shaping the future? Maybe the people in your life who always listen, maybe the habits that give structure to your days, maybe your own unspoken dreams working steadily below the surface. The lake has taught you something not through words or drama, but through its very being. That stillness is not the opposite of change. That hiddenness is not the absence of meaning. And that pressure, even immense, can lead to transformation. Now gently, slowly, the lake begins to fade, not because it vanishes, but because you begin to rise. The water grows colder. The ceiling of ice above grows brighter. You feel yourself moving, not upward, but outward, away from the secret heart you've just explored, carrying with you everything it has offered. And now, let's begin to drift into rest. Let your breath soften now. Feel your body sink a little deeper into whatever holds you. Your bed, your blanket, your night. The lake is behind you now, still whispering in the darkness beneath Everest, but your thoughts are free to rise like mist from its surface. The glacial water grows still again. The microbes pause in their slow dances. The tunnels collapse gently into silence. Nothing is in a hurry, and neither are you. The journey has been long, but you haven't needed to rush. You've traveled through pressure and warmth, through networks and memories, through life and stone and time. And through it all, you've seen how the most extraordinary wonders can exist in the most hidden places. There is a comfort in knowing that not everything must shine to be valuable. Not everything loud is what lasts. Tonight, you can rest in that quiet truth, that somewhere beneath the mountain, something is always becoming. Quietly, gently, patiently. And so are you. If you've enjoyed this journey, I'd be quietly grateful if you'd give this video a like or tap that subscribe button for more peaceful explorations with the Sleepy Scientist. It helps more than you might imagine. And before you drift off, I'd still love to know, where in the world are you listening? From what time it is there? Leave a comment if you're feeling cozy enough to share. It's always a quiet joy to see this sleepy little community ripple across time zones and continents. Good night. Sweet dreams.